Hello folks, we are coming to the part 3 video of this exercise 5.7. The same story we are continuing, but only thing, little bit of change is there. Like earlier we used to just find the second derivative, keep it like that, but here in most of the problems they have asked us to prove something. So we'll be taking the proofs and we'll be showing it. So that's what is going to be our next logic. So let's start right away. This is our problem number what? Problem number 11. So let's start. Y is given like this. So let y be 5 cos x minus 3 sin x. Quite relatively easy function. Then you take the derivative. When you take the derivative, you are taking the derivative of these terms. Cos x minus 3 times derivative of sin x. So it is going to be, for cos x it is sin x, and for sin x it is cos x. Right. So we are right away ready for taking the second derivative also. So that is minus 5 derivative of sin x and minus 3 derivative of cos x. So like that this will come to minus 5 cos sin x derivative is cos x and cos x derivative is sin x. That means this is like writing minus 5, you could take it outside, minus 3 sin x, which is also y. To check? Yes. So as a result, that's what they are asking, y double dash plus y equal to 0. If you could take it on the other side, y double dash plus y equal to 0, minus, no? So it goes there, becomes plus, or rather in other words, d squared y plus by dx squared plus y equal to 0. That's what they asked us to prove. Hence, proved. Actually, very happy to see this problem, a simpler one after quite some time. All has been like product complicated, too much of work. This is quite easy. The next question is y equal to cos inverse x, and you have to write this in terms of y itself. Okay. So here we have y as cos inverse x. So x will become cos y. Yeah. We'll just try. We'll try the reverse way, and then we'll see if we are getting stuck up. Then we'll come back. Okay. You should allow me to give it a try. Let's take derivative with respect to x on both sides. So what will happen? Dx by dx, and this is d by dx of cos y. Dx by dx we know is 1. Derivative of cos y with respect to y is minus sin y. But this is with respect to x, so we should write dy by dx. Right. So what are we left with? This can go there. So it will be dy by dx left, and this will become minus 1 by sin y because it goes there. So dy by dx becomes minus cosec y, right? And yeah, so we can take the next step is taking the derivative with respect to x. So another derivative, so d squared y by dx squared. We have to take the derivative of with respect to x of minus cosec y. So see, cosec y derivative is cosec cot. So this is going to be minus cosec y cot y in terms of with respect to y, but this is with respect to x, so it will be dy by dx in terms of y they want. Yeah, so minus cosec y cot y dy by dx, we know it is what? It is minus cosec y, right? So what happens? We are getting positive cosec squared y cot y, cosec squared y cot y. Let me see if that is the expected answer. That's it. Right. So that's it. Cosec squared y and cot y. For a change, because otherwise we could have done it. It becomes slightly clumsier. So this one. Okay. Next we go to the next question. Cos log x, sin log x, and all. Just 2-3 problems back we did. I think in the 11th. No, in the 10th problem. I'll check. In the 10th, I think. Yeah, in the 10th problem we did. So traces of that we will take it from there, and then we will take the derivative. They have asked us to show something by 1 by 2, we have to do it. So here first we start with y1. Y is already there, so there is no need of introduction. So it is like 3 times derivative of cos log x and 4 times the derivative of sin log x. Okay. Now cos log x and sin log x will not break our heads to do that because we have just done it in the 10th problem. So we can see from there and we can write the answer. So the derivative of cos log x is minus sine log x by x. Why we got it? We got it from problem number 10. And derivative of sine log x is cos log x by log x derivative is x. So like that, overall what we are getting? We are getting minus 3 sine log x plus 4 cos log x whole by x. Then they are asking us to find out okay, x squared y2. Before that, let's take this x on the other side. xy1 is minus 3 sine, you can take it the conventional way, but I think here this will work better, cos log x. What we will do, we'll take the derivative with respect to x on both sides. So what we are doing is, we are doing d by dx of xy1 and d by dx of these terms. Minus 3 sine log x plus 4 cos log x. Okay, now this is a product. So x into derivative of y1 and y1 into derivative of x with respect to x is 1. So no need to write this much only. Now on this side it is derivative of this term plus derivative of this term. Derivative of sine log x is cos log x by x, and derivative of 4 cos log x is minus 4 sine log x by x. This is overall by x, so that x can go there. So this whole thing multiplied by x means x squared y2 plus x y1 is minus 3 cos log x minus 4 sine log x. Is it something familiar to us? Yes, it's y. It is minus y actually. If you take the minus out, then it is minus y. And that minus y, you can bring it on the other side, so that's that expression. Okay, now this comes only by practice. If you are a beginner, what you are going to conventionally do is, you are going to find out y1, you are going to find out y2, you are going to put in that equation and you are going to get the answer. This is after continuous seeing, we know that we could have done this here also. After continuous seeing the problem, maybe you come to know that you could do it like that. But as beginners, we will follow the conventional way, no harm in it. That's why we have to get familiarized with such techniques, so that when you see the problem, you know, probably this could work. Right, so that's where practice matters. Because so many problems will come to know, yeah, this could work better. So therefore x squared y2 plus x y1 plus y equal to 0 is proved, or hence proved, whatever. So that's about it, and then we'll move to the next question. That is this mn kind of things. So let's go there, and y is given to us here. Right away, let's take y1. Now see, when we write this dy by dx, it's clumsy. We'll write y1, y2, and then when we have to revert back, we'll revert back properly. So y1 means derivative of both terms. That is derivative of a e raised to mx plus b e raised to mx. First, the derivative of this a e raised to mx is n e raised to mx. We know it. So it is a n e raised to mx. Derivative of this bn e raised to nx. Now y2, m plus n times y1 they are asking. Let's do it then. M plus n times y1. Now you should always have an I there, then only your work will be simpler. So that means it is m plus n times this a m e raised to mx b n e raised to nx. That means it is a m squared plus mn times e raised to mx and b m n plus n squared times e raised to nx. Term wise, it's going to be a m squared a e raised to mx, a mn e raised to mx, b mn e raised to nx, b n squared e raised to nx. Right, so that's about y1. Now y2, let's see. Therefore y2. So y2 will take this. We have just kept it ready. y2, it is again derivative of these terms. a m e raised to mx, bn e raised to mx, which is an squared e raised to mx and bn squared e raised to nx, right? Because it is e raised to nx derivative is n e raised to nx. That's it. So y2 is there with us. Now we will take what? So consider y2 minus m plus n y1 plus mn y1. So y2 am squared e raised to mx plus bn squared e raised to nx. Then we are taking minus, okay, so all terms, minus am squared e raised to mx minus amn e raised to mx minus bmn e raised to nx minus bn squared e raised to nx, and mny means it is amn e raised to mx and bmn e raised to nx. Very good. So you have this and this cut, you have this and this cut, then am squared can be cut, this can, everything is cutting, that's how it's becoming 0. Yeah, so that's how we are proving that required thing, hence proved. Right, that's about it. So what we've done, whatever expression was given to us, we've proved that that is 0 in all these expressions. That's about it. Some more problems that we are meeting in the next video. Thank you.